Yeah, hello everyone. In the last class, I discussed about the basic introduction part of Java, right? What is meant by Java, who invented this programming language, and which software we need to install to write the code, basic hello world programming Java, and where we can use this Java programming language, and the history of Java. So why the name came Java? So history about the name J. All the topics I covered in the class. Now in today's class, I will be going to explain about some features of Java. So these are total 12 features that I will be going to cover in. Um, these are the total 12 features. One is object-oriented, simple, secure, platform-independent, robust, portable, architecture-neutral, dynamic, interpreted, high-performance, multi-threaded, distributed. All these are the features of Java that I will be going to explain you each and everything. So the first one is simple. So we are calling Java as a simple programming language because the syntax is very clear and clean. So the syntax is clear and some of the tough concepts or some of the complex features which are present in other languages like C or C++. Like if you take the pointer concept, operator overloading concept, these are the complex features which are present in this programming language like C and C. These complex features are removed in this Java programming language to make it simpler and easier to write the code. Okay, so that's why we are calling it as a simple programming language. And object oriented means Java is completely an object oriented programming because it is completely deal with class and objects. So in Java, we'll write the code. We'll start with the code with class keyword. So Java program always start with the keyword class since it is always includes the class and objects here. So there are these some features of a OOPS, encapsulation, abstraction, polymorphism. All these OOPS features supported by the Java. Means Java supports all these OOPS features. So each and every feature you will be understand when we discussed about the OOPS feature. Just remember, Java is an object-oriented programming. Everything is related to the class and objects. Means Java program is always start with the keyword class and everything in Java is treated as an object only. Okay. So what is this? Will be going to discuss in the next classes. Next, platform independent means whatever the code we have written in C, if you take an example of C, this code will not work for all operating systems. Like suppose you have written the code for Windows operating, it does not run on Linux, it does not run on Mac. It will only work for Windows. That is a C is dependent programming language. Means whatever the code you have written for particular operating system, that will work. Your code only will run on that Windows operating system only. It does not run on other operating systems. Okay, so see that's why it is called. This feature is called as a dependent feature. It does not work for all operating systems. But when it comes to the Java, so it is called as a platform independent language. This is the major difference between other programming languages and the Java programming language. Is platform independent feature, which is the main part. So what is the major difference between other programming languages and the C? Like C and Java is platform dependent and independent. C is a platform dependent, Java is a platform independent. So how we can run our Java code on any operating system? If you write the code on Windows, how does it works on Mac or Linux means? So we are converting the code into machine code in two ways. The first one is whatever the code we have written that is called as a Java code. That code will be compiled using compiler. So here the compiler will verify the code. Is there any error present in our code or not? Using compiler. After compilation, if there is no error, then this compiler will generate a bytecode. Okay. So this is not an output. This is not an output. It is a bytecode. It is nothing but a dot class file. Okay, so dot class file is nothing but a bytecode. Bytecode is nothing but a dot class file. So this dot class file what we have converted using compiler is after compilation, this dot class file will be shared to any operating system using JVM. Okay, here JVM plays a major role. With the help of JVM only we can achieve this platform independent feature. Okay, so with the help of JVM we are able to run our Java code on any operating system anywhere. That's why we are calling it as Aura. Write once, run anywhere. ఓకే. సో, ఒక్కసారి రాసిన కోడ్‌ని మనం ఎక్కడైనా రన్ చేయొచ్చు విత్ ద హెల్ప్ ఆఫ్ జేవీఎం. సో, ఎలా అంటే దేన్ని మనం రన్ చేయొచ్చు, కన్వర్ట్ చేసిన డాట్ క్లాస్ ఫైల్‌ని మనం ఈజీగా షేర్ చేసి ఎక్కడైనా రన్ చేయొచ్చనమాట. ఓకేనా. నెక్స్ట్ సెక్యూర్డ్. సెక్యూర్డ్ అని ఎందుకన్నాము అంటే, సో వన్ ఆఫ్ ది టఫ్ కాన్సెప్ట్ ఆఫ్ పాయింటర్స్ కాన్సెప్ట్ హాస్ బీన్ రిమూవ్డ్ సిన్స్ ఇట్ డస్ నాట్ అలౌస్ direct memory access. Java does not allows the direct memory access since there is no pointers concept here. Okay, so మనం డైరెక్ట్ మెమరీ యాక్సెస్ అనేది రిస్ట్రిక్ట్ చేసాం బికాస్ ఆఫ్ నో ఎక్స్ప్లిసిట్ పాయింటర్స్. Implicitly we use this pointers concept, but we are not going to use this pointers concept here. ఓకే. నెక్స్ట్ ఇంకొక పాయింట్ ఏంటి అంటే, సో వీ హ్యావ్ ఎ బైట్ కోడ్ వెరిఫైయర్. మీరు ఆల్రెడీ కంపైలర్ యూజ్ చేసి మీ ప్రోగ్రామ్‌లో ఎర్రర్స్ ఏమైనా ఉన్నాయా లేదా అని చెక్ చేస్తున్నారు కదా! సో చెక్ చేసిన తర్వాత మనకు జనరేట్ అయిన కోడ్ ఏంటి? దేర్ ఈస్ నో ఎర్రర్ ఇన్ యువర్ కోడ్. దట్ ఈస్ బైట్ కోడ్, రైట్? Again this bytecode verifier, it is present in JVM. It will verify this bytecode again. So bytecode verifier will verify this code again. Is there any untrusted code present in your program or not? Okay. So ఇక్కడ కన్వర్ట్ చేసిన తర్వాత మళ్ళీ ఏమవుతుంది అంటే బైట్ కోడ్ వెరిఫైయర్ మళ్ళీ బైట్ కోడ్ని ఆ డాట్ క్లాస్ ఫైల్ని మళ్ళీ రీవెరిఫై చేస్తుంది. సో ఇలా 2 స్టెప్ వెరిఫికేషన్‌లో మళ్ళీ మనం వెరిఫై చేస్తున్నాం కాబట్టి సో ఇట్ విల్ ప్రొవైడ్ high security. So there is no chance that data leakage. Next, robust programming language. We are calling Java as a robust programming language because we have a strong memory management. So how we are able to manage this memory means in Java we have an automatic garbage collector. So this automatic garbage collector, what does it do means? So suppose if you take a house, if any unwanted or unused thing is present in your house for a long time, it is not being used. So what do? It you'll just throw it out, right? So why we are storing it unnecessary if it is not used? We just throw it out to store the some other things in our home. In the same way, in our program, some of the objects you have created, but you are not using it throughout your program. Once we created, it has to the object has to occupy some memory, right? It will allocate some memory. So each and every object stores in some memory. So if you are not using it throughout your program, then unnecessarily why do we need to assign the memory to that, right? It's a waste of memory storage. So what happens here, the automatic garbage collector, if any unwanted or unused objects present in our program, if it is not used throughout a program, then such kind of objects will be destroyed or deallocate memory. The automatic deallocation and automatic allocation of the memory to the object, automatic deallocation of memory to the object will be handled by this automatic garbage collector. So what does it do? If any unwanted and unused object present in our program, it is not used throughout the program, such kind of objects with memory will be deallocated when we are running this program. Okay, so that we can save the memory uses, we can store another object which we are using in our program. In this way we can store the we can store the objects and we can save the memory, right? And another important point here, we can say the Java is strong. We have an exception handling feature. It is nothing but, so suppose you have written some application, right? You have built a calculator app and here you are asking, so user want to do some calculation. Um, so your program is ready to take an input for numbers like 1 to 9, 0 to 9. So basically calculation is do for numbers, right? But you are asking user to enter the numbers. What do you want? Suppose I want to do calculation of two numbers addition. Instead of I am entering 1, 2, I'm entering A and B. Can we do addition for A and B? No, right? 1 plus 2, we can do it. That is, both are numbers. So A plus B, how does this calculator will give the output? How does it generate such kind of inputs if user enters? Means that is unexpected. Means user has to enter the digits from 0 to 5. If your program is not ready to take such kind of inputs, if your application is not ready to handle that such kind of inputs except 0 to 9, your program will crash, right? It will display some error. So instead of error, why can't you generate an output like sorry, enter wrong input, please try again, enter correct input. If you are handling such kind of situations, then your application is well and good, right? We are able to handle that situations also using this exception handling concept. One second. Sorry. Next, I hope you understand about this robust programming language. We are able to manage the memory if any unused object present in our program, that will be deallocated. The memory will be deallocated, and if any unexpected situation occurs in our program, that will be handled by the exception handling concept. Next, architecture neutral. So here we are calling a Java is architecture neutral, means whatever the code we have converted, that bytecode will be not hardware specific. Means it will not create an output for based on the architecture. Whether you may use 32-bit or 60-bit, 64-bit processor, it will work for any type of processor. Whether you are using Intel, ARM, any type of architecture you may use, it will generate the same kind of output. It is not hardware specific. So for 62-bit, for 32-bit, it will not generate one output. For 64-bit, it will not generate a different output. Any architecture, it will generate the same output. That is nothing but architecture neutral feature. Okay, next, portable. Yes, we are able to share our code and we are able to run our Java program on any operating system. Portability means easy to share. Yes, we are able to share our code, right? With the help of JVM, we are able to run our code. That is a feature of the portability, means easy to share. After compilation, whatever code we have converted into the .class file, that will be shared to other operating system using JVM. We are able to execute. We are able to execute the program using JVM. Means that we have a feature that we can easily share the code. Next, that is nothing but the portability. Next, high performance. In Java, we use the compiler and interpreter and just-in-time compiler, interpreter, and JIT compiler. So what this compiler will do? Compiler converts the code, whatever that we have written, into bytecode, right? This bytecode will be converted into the machine understandable code, machine code, with the help of interpreter and just-in-time code. Interpreter works slow because it will execute line by line. Compiler checks the whole program. When it comes to the interpreter, it will execute line by line since it is a little bit slow. So to improve the performance, we are using this just-in-time compiler. So how does it works means it compile the bytecode and convert into the machine code at the runtime so that we'll get the better performance, right? Interpreter, since even though interpreter is we are using, will get the better performance because of just-in-time compiler. How does it works? It will compile the bytecode and convert into the machine code. Okay. Next, multi-threaded means so you have written some 100 lines of code, 1 to 100, right? To execute, suppose let us assume this 100 lines, to execute this 100 lines, you 100 seconds of time it takes. Okay, so if you write 1000 lines, 1000 seconds, 10,000, 10,000 seconds. So what happens here when the program length is more, it takes more time to execute the code, right? So what we are doing it, if your program contains an independent part, means uh, suppose 1 to 50 and 50 to 100, there is no interconnection between these two lines. If each 1 to 50 is one program, means one part of the program, 50 to 100 is another part program. Why can't we execute these two parts parallelly to save the execution time? Means both are not interconnected. There is no connection between these lines and these lines. If both are independent to each other, then such kind of parts will be executed parallelly. So each independent part is called as a thread. Okay. So each independent part of the program is called as thread. These threads will be executed parallelly so that we'll get the better execution output. So instead of taking 100 seconds, we can complete this program, we can execute this code within 50 seconds, right? Because both are executing parallel. There is no interconnection between these two threads. If there is an interconnection, again it will be slow. Like it has to wait for the output until it executes this line, then it will get the output, right? Um, so thread is nothing but an independent part of the program. It will execute parallelly. Multiple threads executes parallelly so that we'll get the better execution, better response. So we are going to achieve this feature using multi-threading. Next, Java has a rich library like uh, AZB, a remote method, invocation, all these a set of APIs Java has to build a distributed applications. And since Java is a dynamic, we are able to load the classes dynamically when we are running a program. And because of the JIT compiler, we are converting the bytecode into function code at runtime to improve the performance. Even in we are using a interpreter and to get the better performance or high performance. This is the flow of the execution part. Whatever the code we have written, that will be saved with .java extension, that will be converted into the .class file using javac command. After it converted, we are loading it to the JVM. JVM has a class loader. It will load the .class file, and using interpreter, we are running the code, and using just-in-time compiler, we are converting into machine code. Okay, so this is the interpreted feature. Finally, these are the total 12 features of Java that I covered here. I hope that today's topic is clear. So, uh, object oriented means everything is related with class and objects. Let's have a vision of this. Like simple means some of the complex features which are present in other programming languages like C and C++. Like if you take pointers concept or operating overloading concept, these are the topics, complex features are removed in Java. Secure, we are calling Java as secure because even we converted into the bytecode using compiler after checking the errors. Again, we are verifying that bytecode using bytecode verifier. And there is no pointers concept here, explicit pointers concept here. Here we are restricting direct memory access. So that's why we can call the Java as more secure. And platform independent means we are able to run our Java code on any operating system using JVM. It is a feature of platform independent. Next, robust means we are calling Java as robust programming language because we have a strong memory management. How we are able to manage the memory? Because so when any object is created in our Java program, it is not used throughout a program. That memory reallocation will be handled by the automatic garbage collector. So next, portability. Yes, we are able to share our code to other operating system and we are able to run that. So easy to share feature is available in Java. There is nothing but a portability. Next, architecture neutral. So whether it may be 32-bit processor or 64-bit processor, Intel, ARM, whatever the architecture you are using, whatever the processor you are using, it will not generate different outputs. Any architecture, any processor, it will give the same output. It will run in the same way only. That is nothing but architecture neutral. Next, dynamic. Yes, we are able to load the classes and we are able to run a Java program at runtime. That is the feature of the dynamic. Next, interpreter. Yes, we are converting the Java code into the bytecode using the compiler. After converting the bytecode, we are able to run Java code. We are able to execute that code using the interpreter. We are converting into the bytecode using compiler, and we are able to run Java code using interpreter. High performance. Yes, we are getting high performance because even we are using interpreter to execute the Java code. Instead, we have a just-in-time compiler. It makes better performance. How does it works? It will convert into the machine code by after converting into the bytecode. Okay, so because of this JIT compiler, we are able to get this good performance. Next, multi-threaded means, so when you have a multiple lines of program, and if any independent part is present in your program, each independent part is called as a thread. Multiple threads, if parallel executes, we can save the execution time. We'll get the better output. Okay, so that is concept of multi-threading, executing multiple threads parallelly to get the better performance. So each thread must be independent part of each other. It does not depend on other thread, so that we can achieve this multi-threading. Distributor, yes, Java has a rich API and it is helps us to build distributed applications. Finally, these are the total 12 features of Java. I hope it is clear. If you have any doubt, please let me know. Please do it. Please do mention in the comment section. If you have watched this video till the end, please give some feedback about my lecture. So what I need to improve means, am I going slow or am I going fast, or else is my teaching methodology is good or bad? What I need to improve. Okay, so that I can also improve. I can also change my teaching style. Thank you for your valuable feedback if you have submitted. That's all for today. Thank you, everyone. We will meet you in the next class.